Hello, welcome to the video on predicting traits for incomplete dominance. So when you open up, you see these two wobbles here. I have two wobbles, one that is blue. Here we can see that blue has the trait capital B. Right? And then we see that we have a yellow one over here. We know that yellow is going to be a lowercase b. Right? That tells us that the blue skin is going to be our dominant allele, and our yellow skin is our recessive allele. Right, so if we were to come down here to our Punnett square, all right, let's go ahead and fill this out. So we have one parent, right, that was blue. Doesn't really matter if you put the blue in here or here. I'm going to go ahead and put them here with two capital B's. All right, we have this genotype right here, two capital B's. For our yellow parent, we'll go ahead and put them across the top here. We have two lowercase b's. So when we do the cross, right, each square here is going to get one from each parent. So we get the capital B here. And we get the lowercase b here. For the top right quadrant, you get the capital B from here. You get the lowercase b from here. All right. Same thing for these ones here. They both get a capital B from the row, and they both get a lowercase b from the column. All right, so we can see that all four of these are identical. They're all heterozygous, right? You all have a dominant allele and a recessive allele. So if I look at results, well, how many had a capital B, capital B? I don't see any of those. So we had 0 with that genotype. Same thing for lowercase b, lowercase b. We have 0 of that genotype. Capital B, lowercase b, all 4 of them were. So what's our ratio? Let's say 0 to 4 to 0 ratio. For phenotypes, right? Phenotypes are what it looks like. All right, so we would say it could look either blue or it could look yellow, right? And we'd say, well, yellow is recessive. So if you have a dominant allele, if you have a capital B, right, you should show that dominant trait. So we would expect to see 4 blue, and we would expect to see 4 0 for a ratio of 4 to 0. All right, you could then come down here and color your little wobbles. I'm not going to color all of them because it would take too long, but that's what we would expect. Right. If we come down here, we see that's not actually what happens though, right? When we have our blue and our yellow cross, we end up with green ones. All right, so there's a lot of information on this page about what's exactly is happening here. The big term for it is incomplete dominance, where the dominant trait doesn't have 100% of it showing. Right? It doesn't show 100% of that trait. It's kind of a mix between the two. All right. So if you look at these roses, I'll do these two examples for you on the worksheet. All right, we can see that we have a red rose and a pink rose. All right, there's also white roses. The white roses are homozygous recessive, so it would be a lowercase r, lowercase r. These pink ones have the incomplete dominance, where you have a capital R, lowercase r. And then you have the one here that is homozygous dominant, capital R, capital R. So let's go ahead and do a cross between this red rose and this pink rose and figure out what kind of offspring we would get. All right, so just like before, right, we would take the pink one. It doesn't really matter which parent you use. I'll use the pink one. And we would put its alleles on the top here, capital R, lowercase r from right here. For the red rose, we have a capital R, and capital R. All right, just like every other Punnett square, we'll take this r, bring it down. All right, and we'll take this lowercase r and bring it down. All right, going across, here we have a capital R. All right, just capitals always come first, just makes it look neater. And then bring this R across here as well. And we have our probabilities here. All right, so our genotypes, we have 2 that are capital R. We have 2 that are capital R, lowercase r. And we have 0 that are lowercase r. So this is a 2 to 2 to 0 ratio. Well, what does that mean? Right? What does a genotype of RR mean, of capital R? We see here that capital R means that you are a red rose. So we'd expect to see 2 red roses. If we have a capital R, lowercase r, we know that means pink. So we would have 2 pinks. Lowercase r would be white. We don't have any of those, so we would say 0. So our ratio is still 2 to 2 to 0. What's our probability of the offspring having pink flowers? Well, we just said that 2 out of every 4 will have pink flowers. Right? The other 2 out of the 4 would be red. All right, what is 2 out of 4? Well, if you make 2 out of every 4 shots, you are shooting 50%. Right? You have a 50% probability that your offspring will be a pink rose. I'll do this one as well. All right, so for this one, we have a white flower and a pink flower. The white flower is homozygous recessive to lowercase r's. The pink flower is capital R, lowercase r. Right, it's heterozygous. And let's go ahead and fill out our Punnett square. Bring this capital R across. Bring this lowercase r across. And then coming down, we have lowercase r's in both cases for both columns. All right, so what do our offspring have? Well, we have 2 that are heterozygous, capital R, lowercase r. We have 2 that are homozygous recessive, lowercase r. We have 0 that are homozygous dominant because the white flower didn't have any capital R's to give for this offspring. So our ratio is 0 to 2 to 2. As far as the phenotypes go, capital R is red. We don't have any of those. Capital R, lowercase r is pink. Right, we have 2 of those. Lowercase r is white. We have 2 of those as well. So 0 to 2 to 2. What's the probability of our offspring having pink flowers? Just like before, 2 out of these 4 boxes have pink flowers. So our odds are 2 out of 4. And just like before, that means you have a 50% chance. The process is exactly the same for the rest of this worksheet. All right, you just follow the exact same process we did up above. Just like always, if you have trouble, shoot me an email, send me a message in Canvas, and we'll get you on your way.